Hello everyone, we are back with another part of the bullet hell series. Now in this episode we're going to add a script to our player so that we can move them around the game scene. To do this, the first thing we want to do is to go to our player object, add component, new script, and then we can call our script whatever we want to. I'm going to call mine player bullet. Now one thing that we need to make sure of is that we've got our language set to C#. So if it's on Java for some reason, just click on this and on the drop down click C# and then press create and add. Once we've done that, we'll realize that our script has appeared in our assets area. Now what I've done is I've already created a scripts folder because I was messing around with a couple of scripts before this. But if you want to create your own folder, then right click on the assets branch, go to create folder, and then just name the folder whatever you want. In this case it will be scripts, and then drag this piece of script over to the folder and you'll find it in here. Okay, now to opening our script. One thing that you can do to open your script is to either double click here or just click open here, and then we'll be taken into MonoDevelop, which is Unity's platform for compiling code. Okay, now that we're in MonoDevelop, let's get rid of the sample code and start our own thing. Now, just a bit of a heads up for everyone. First things first, make some squiggly brackets here. Press enter, and then in the middle of those brackets, press enter again. And we're gonna do void fixed update. Now, one thing that I'm just going to preface this part with, everyone, is that I am not an expert at coding and scripting. I know the steps to take to get where we want to get, but a lot of the things, a lot of the terminology kind of eludes me. So one thing that we can do, and that you can do alone while you're watching this video or working on another project, is if you want to find out what something does, you can highlight it and then hold Control and press the apostrophe key. Now once we've done that, we'll be taken into Unity's scripting API, which is basically where we can find definitions for different things. So for fixed update, we see that this function is called every fixed frame rate frame. So we're going to be making a series of lines that will dictate that when our player inputs a certain thing, so when they hit an arrow key, something will happen, and this will happen every frame due to fixed update. That's from my own understanding. That might not be 100% accurate, but doesn't mean we can't continue with our script. So, two squiggly brackets again, hit enter and open those up. So I'm going to come back with some finished lines of script and just explain what those do. So here we have two float sort of lines. So these two lines of code dictate how the player will interact with the game, as these ensure that when the player inputs a certain thing, a certain outcome will happen, which is going to be that they'll be able to move around the player object with the arrow keys. Now we made a rigid body component earlier, and that was not just for me to like mess around with the gravity and stuff and just to make that a nice little cliffhanger, but it actually allows us to change, manipulate the physics of the player object. Now to do this we have to address the rigid body component, so we're going to type this next line of code. Here we've addressed the rigid body component, but what do we want to do with that information? Well, we want to add physics to our actual player so that we can move them around using the arrow keys. So our next step will be to add another line of code that allows us to do this. Now here we've made a new variable for movement, and we've assigned that to a new set of vector3 values. Now this new vector3 addresses the x, the y and the z dimensions, and we're going to assign this to the movement of the player. Now we don't want our player to be able to move along the y, because the y, as we can see in our scene view, the y would be up and down movement, and we don't actually want them to move towards and away from the camera. So to restrain that, we're going to set that to 0.0f. Now our x movement is going to be our float value, which is move horizontal, so we're just going to put that in there. And our Z value is going to be set to our float value, move vertical. Now the next thing that we're going to do is add a public float. Now in this line I've created a public float which is speed. This will allow us to change the velocity of our object once we apply the correct code. So next we want to add a line of code that will affect the velocity of the object. So I've come up with this line of script that says the velocity of the object is equal to the movement times the speed. Now we've made speed a public float, which means that we can view it in the inspector and change the value of speed. And movement is a variable that we've created that dictates that our player is going to move horizontally and... oh, I messed that one up. Just make sure that this is set to vertical. And then if you have made the same mistake, then just copy and paste that in. Once we have our script looking like this, we can return to Unity and see how things are working. But first, we just have to go to File and then save our script. I've already done that. So now we can go back to Unity. In Unity, all we have to do now is just hit the play button to see how our games come along. So we've hit the play button, but our player isn't actually moving. And even though I'm hitting the arrow keys, nothing's happening. Now this is because speed is set to 0. And if you remember, movement times speed was the velocity of our object. So movement times nothing equals nothing. So let's just change that real quick. I'm going to take the movement of my player up to 10 and see how that works for me. Now in the play mode we can see that our player is moving as we want it to. But there is one issue that we find. We can actually escape the scene. So what we want to do is we want to go back to our script and create a boundary for our player. Now creating a boundary is going to be a little bit more complicated and is going to require me to explain things step by step, which won't be too great. So what I'm going to do is I'm just going to finish up my code and then explain what I've done to put in the boundary. I'll put some sample code in the description so you guys can try this out for yourself, and I'll be back in a second. Okay, so we're back. Now the first thing that I'll note is that I have created a public class for boundary. I've called it boundary1 because I've already got a player move test, which I just used a second ago, that already has a public class named boundary, and Unity won't allow us to have two things named the same thing in two separate scripts. And I've used system.serializable to serialize our boundary so that Unity recognizes it as something that we can see and manipulate. What we want to manipulate is our public floats, which are xmin, xmax, zmin and zmax. And these are attached to this function called mathf.clamp. Now what these mathf.clamp lines do is that they allow us to constrain the movement of our player by setting 2 points at which our player cannot go past. These are a minimum value along the x-axis and a max value along the x-axis, and the same with the z-axis. Now the y-axis, we've left that at 0.0f because we don't actually have any movement along the y-axis. To make these all relative to the space that we're using, I added another new vector3 component and labeled this as rigidbody.position. Another thing to note, if you've copy and pasted your code from the sample code that I left in the description, then there are a couple of things that you will want to change. Well, just one thing mainly. Now the public class here, player bullet, is the same as the name of my script. Make sure that this, the name of your script, is the same here. If not, then it won't work, and that will just be an issue that you'll have to fix upon playing. Once we're done here, we just save our script and then return to Unity. Now in Unity there are a couple of things that we can see on the inspector. We have a new boundary class that has a set of drop downs. Now these include xmin, xmax, zmin and zmax, which I described set the boundaries along our scene. Now if we go into play, let's see how our boundaries are working right now. As we can see, our player is in the middle of the game and not really able to move. We can move him a little bit, but we just get sucked back to the original point. Now, the reason for this is that we haven't actually set our boundary point above 0, so it just wants to pin us down to the middle of the game. So what we want to do is find out where our boundaries are set. So let's find the minimum value, and that is -4. Now what's our max value going to be? Well, seeing that our player was in the middle, we can safely assume that it will be +4. Let's find our Z value. I think I'll leave that at -6.5. And this will be the same with our top Z value, if we want our player to reach the very top of the screen. You might not want to, you might want to restrain them to here. If so, then just put in a lower value than that. Now let's reset where our player was originally. And see how things play out. Okay, so there we have it. Our player's moving pretty well. We've got fluid movement. We've got enough movement so that we can make we can get out of the way of things quickly, but we can also make small adjustments to our positioning. And we've got a boundary set so that our player doesn't leave the sight of the main camera. In the next lesson, what we're going to do is create some shots for our player and make that into a stream that our player will constantly put out. Anyway, that has been this part on the bullet hell tutorial. I hope you guys enjoyed. Remember, the sample script is left in the description below. And if you liked the video, then leave a like. If you want to comment something, if anything's troubling you, then just leave a comment. And thank you for supporting. Have a Merry Christmas, everyone, and I will see you later.